Let's do some of these exercises from tracing code worksheet number 1. In exercise 1, the variable num a is an int, so I set it equal to the value 3. Num b is a double, so it can store decimal places. It stores 4.2. And num c. Num c is an int, so it can't store decimal numbers. So when you add 3 plus 4.2, the answer, of course, is 7.2. This part of the right-hand side works out to be 7.2. And you cannot store a decimal number. You cannot assign it into an int. So that's an error. We never make it to the system out print statement. Keep in mind that when you read the directions here, you have to print error as an answer. And in this case, the explanation is you can't store a double into an int. Next exercise. We have this variable named number, but it's really a string. It has double quotes around it. The parse double method from the double class, it converts a numeric representation of a string into a number. So it rips off the double quotes. So we have 3.3, and when that's added to 2, we simply have 5.3. So 5.3 is stored in the variable numbers. And on the system out print statement, 5.3 plus 0.4 yields 5.7. So the answer is 5.7. Number 3. It is legal to declare two variables in the same line of code. I don't like to do that because of my coding standards, but num1 is equal to 3 and num2 is equal to 2. Okay, sum. Sum is a double, so it can store decimal places, which isn't an issue here. So 3 plus 2 is simply 5, and 5 is the value stored in sum, so therefore 5 is the value that's printed by the println method. In the next statement, num4 is never initialized. It's not even initialized to the value 0. So that's an error. Num4 not initialized. Num4, and number 5. Num_m is a string. It's equal to 1,4 in double quotes, and num_n is 3,2 in double quotes. Notice I do not pronounce these as 14 or 32. But rather the string values 1,4 and 3,2. When Java executes the println argument, it works from left to right. The number 56 is concatenated with the string num_n. Because one of those two arguments or more is a string, Java treats the plus as the concatenation operator. So far we have 5, 6, 3, 2 in a set of double quotes. And when that is furthermore concatenated with the string num_m, which is 1,4, the whole thing ends up being 5, 6, 3, 2, 1, 4 in a grand set of double quotes because the whole thing is a string. In the next exercise, we have a long string named message. The substring method goes to the position of the first parameter, 3. Count with me, starting at the A as 0, 1, 2, 3. That D is in position 3. And we go up through, but not including the element in position 4. Well, the E is in position 4, but because of the way substring works, we don't include the E. So the printed value is simply the letter D. The letter that's in position 3 of the string message. Next, it is legal to substring a string literal that's in double quotes. When substring only has one parameter, we count in the number of elements starting at 0, 0, 1, 2, 3, 4. So I'm at the V, and you extract everything from the V to the end of the string. So the answer here is the strange word "buts," and I always wrap that in double quotes to show that that's a string. Number 8, this is roughly negative 2 billion. This is the negative of negative 2 billion, which makes it a positive. So they cancel out with each other, leaving 1 as the answer that's stored in num. Even though overflow occurs if you directly assign a number bigger than integer max value or more negative than integer min value, in this case, it does not overflow on the right-hand side of the equals. The value 1 makes it into num because these two guys cancel out before the assignment occurs. In number 9, we have integer division. Because we have two ints being divided by each other, the computer chops off the decimal places. So 10 divided by 3 is typically 3.3 repeating. But in Java, in this situation, the answer is 3. That's what prints out. And finally, in number 10, we have this strange string named digits. And the index of method in the string class finds the occurrence of, in this case, the string 6. Well, let's find where the 6 occurs. Starting at 0, of course. 0, 1, 2, 3, 4, 5. So the 6 is in index position 5. And that's the value that's stored in the variable pos. So we have, on this line of code, we have a 5 added to index of A. Well, the A isn't found in digits. And when index of doesn't find what it's looking for, it returns a -1. Go read my lecture notes or read the string API in order to learn that the index of method returns a -1 in that situation. So 5 plus -1 is 4, which is printed out as an answer to exercise number 10.